from Linaro,
Yep.
talking about load balancing to CFS.
Yeah. Hello. So yeah, I'd like to speak and discuss about reworking the load balance and see what we can do to do a better task placement, at least in some use case. I mean, even if we'd say that probably most of the use cases are now handled, we still have few use cases which are not correctly handled. And trying to fix them, it's just like adding one more switch case in the load balance algorithm. So instead of doing that, we should better have a look at what we have done. So yeah, that's so what we are doing right now and what maybe we should change. So yeah, as I explained, we have some use cases which are not correctly handled yet with the load balance function. And for some other use case, so I will give few use case examples. For some other use case, they are handled, but it seems to be quite random the way they are handled. So, and the goal would be also to simplify how the calculating balance is done by removing, so in this function and especially in the fixed small imbalance part, we have a lot of old heuristic and some, I mean, meaningless in the sense that I think that nobody now know exactly why we have such condition. Or at least I haven't been able to find, and on the list, people haven't been able to explain that to me. And also, yeah, so because of this and different change that happen in the load balance, we have some weird way to calculate the imbalance. And at the end, we are just putting a value and expect that to be enough to fix the imbalance, to create a migration that will then fix all the things. So instead of trying to put some random value, we should better explain exactly what we want. Like, I want to migrate the task, whatever the load or the utilization. I want to migrate this task because it doesn't fit with this CPU. So that's such kind of use case or situation that I'd like to discuss. And part of this rework that would be, so in the load balance mechanism right now, we are classifying the different group of CPU to see which one is imbalanced, which one is overloaded or not. And we have some classification which are really dedicated to a use case. We have the misfit task, for example, which is clearly for the misfit. Maybe we should replace this use case specific tag by something a bit different, like I want to migrate this task or I want to migrate this utilization, so we can reuse that in other use case. And also, and finally, the I mean, since the last couple of years, the metric used by the load balance and the scheduler have changed a lot, but we haven't seen that much change in the load balance mechanism. So maybe we can take advantage of this new metric and do a better job. So some use case. The first one is one that I send a patch on the mailing list. That's the one that triggered this work for me. I send a patch. So we have this use case. It's a big little platform. So 4 little core, 4 big cores. And when you, so I'm not using the EES and energy model. It's just from a pure performance point of view. Or maybe it's enable, but it's the overloaded case. So yeah. So you have 8 tasks running on these 8 cores, but at the end, you have 1 little core that is idle, and the 4 big cores just have to take care of 5 tasks. So that's happened quite easily. It's not always the case. In fact, I have also discovered that depends where the tasks are starting. For example, if the tasks are starting on the big core, it will not be able to migrate on the little core. But if tasks are starting on the little core, you will be able to spread all the tasks. Which means that for the same use case, depending on the starting point, you will not have the same behavior. And that's also something I have been able to reproduce such kind of situation with a RT task stalling some runtime, which means that from a load balance point of view, we are creating this kind of asymmetry. And we are able to create the same kind of behavior. And so yeah, on the mailing list, we are discussing this thermal pressure feature, which can generate the same kind of asymmetries in the capacity. So we can typically face similar problem. So for all this case, in fact, when you can see that there is some migration typically, and in all case, when the load balance try to migrate, we finish in the fixed small imbalance function, which is when we are in a situation where we are not able, it's not clear what we have to do. So we try to fix that. So as I mentioned, the initial task placement has an impact on the result. But also, if you have any question, don't hesitate to interrupt me. But also, that also depends on the weight of the task, and mainly because in the fixed small imbalance and the way it's computed, we are doing some multiplication and division, and depending of the rounding result, we can trigger or not the task migration. So, which is a bit, so in some case we are lucky and everything work well, but in other case, we are not, we are stuck in the wrong task placement configuration. And in fact, yes, it's mainly because of this asymmetry in the capacity, either because of architecture or because of other stuff. And the default load balance, which is trying to compare the average load balance with the CPU or the CPU group capacity, we are just in the situation where we can have higher average load balance on a group of CPU with less task. So in such case, trying to compare and fix the load average doesn't make any sense. Or at least we should be able to detect this situation and fall back in a situation which is mainly we have to migrate a task. We have one idle CPU and one overloaded CPU, we should migrate a task to fix that. This is another use case which have been raised to me by some members. So the typical use case is that we have a CFS task, the pink one, that start to run. Just after that, a RT task preempt the CFS task. And even if we have some idle load balance that happen, the CFS task is just waiting. And we never migrate this task on an idle CPU. So we are just wasting, or we are just increasing the scheduling latency by 5 milliseconds. And on an Android platform where we have this 16 millisecond period, which is the period that we don't want to miss, waiting 4 milliseconds to finish one step in your sequence can be quite expensive. So, and the main reason for that is that in the load balance, we are only taking it, for the CFS load balance, we are only taking into account the number of CFS tasks that are running. So we are using the number of running tasks to trigger this, but then we are not taking into account the number of running tasks on the CPU. That's why, in fact. So we are triggering that, and then at the end, we don't see any major problems, so we stay in the same situation. So the goal would be to take into account running task in addition to the edge running task to minimize resource contention and to not delay the scheduling of a task. That's also another thing that have been raised on the mailing list recently. It's also taking into account the scaled idle task in order to consider this CPU as an idle CPU and preempt. It's all about improving the scheduling latency in this case. So if we are able to know if a CPU is only running scaled idle tasks and you have two CFS tasks competing for the same CPU, maybe we should migrate one to just reduce by a few milliseconds the waiting time. Don't hesitate to raise a question or to interrupt me. The third one, the third typical use case is that when you have, so this is not a big little, this one is a SMP system. So when you have 9 tasks on 8 CPU, you can't be balanced. That's not possible. So what's happened? So that's what's happened on my platform. So we can see that we have 2 tasks competing for the same CPU from time to time when the task is migrating on another CPU. So in this case, for example, these two tasks, I mean, we are not fair for the 9 tasks. These 2 tasks lost some runtime, some running time compared to the other one. And in fact, so the point is that when and how are we migrating the task in this case? Because there is no solution. We will always be in balance. So right now it's happened. So in this case, the task was not really lucky because these 2 tasks stay almost always on the same. But I mean, if you run that 10 times, you will have 10 different patterns, but it will never be really evenly spread. And that's mainly because, so what's happened is that at every load balance, we finish in the fixed small imbalance. In the fixed small balance, it's used the current load and capacity, just like previously. And it tried to use to balance, to migrate the task. Sometimes it decides to migrate, and some other time it doesn't, without any good reason. I mean, I have tried to find it. It's really a matter of the load and the capacity increasing or decreasing by few units, which is quite small compared to I would say, the stability of our signal. So instead of waiting for fixed small imbalance to do the right choice, we should better look at something less random. I mean, if we know that we are in balance, we should better force the migration from time to time and maybe decide how often that makes sense and on how many CPU. So my goal would be at least to have this simple use case to work properly, which means that if we are not even able to handle a 9 task on an 8 CPU case, I mean, the more complex use case are even more unpredictable. So sorry?
So it's a statically infeasible scenario, but it's a dynamically feasible scenario. Though the proper fix would probably be too expensive because we need a global runtime measure, and thereby you can measure weights of the CPUs has gotten too far ahead and then move there, and then it works with random weight distributions as well.
Yeah.
And all the infeasible weight scenarios.
So yeah, so I agree with you that trying to have I would say equal running time for each is probably difficult, but at least for that, being able to migrate differently. I mean, we don't have to have something really accurate, but
it's intrinsic to the problem, though, right? 'Cause
yeah.
on the previous slide, like your thing, this is load invariant. VRun time is a mix of load and util,
Yeah.
and you need util to actually solve this.
No, my point there, I agree.
And I'm agreeing.
My point there is mainly that we know this imbalance. We're able to detect that because we have 2 tasks on one CPU and the other one has only one. So the goal would be to say, okay, let's migrate that. And if we are not in this situation, and then I expect, I would say, the randomness around that to make sure that we are using all the CPU from time to time. I don't want that to be fair in, I would say, 20 milliseconds, but at least 100 or even 1 second, but at least something large enough. Yeah.
In that case, if you go down that way, you need just 8 tasks and you have asymmetric capacity, you are still on fail, and you should keep migrating the task from small CPU to little CPU.
Sorry, for which case?
Even if you have only 8 tasks,
Yeah.
right, running flat out on those big little CPUs or CPUs with different capacities,
I agree.
you are still on fail.
Yeah.
So really, you should go down to VRun time, which is capacity invariance sort of. Fair because on the little CPUs you can deliver less CPU cycles than on the big. Because the tasks running on YouTube, they deliver less performance than the tasks running on Linux. Don't have the same rate of progress.
Yeah.
If you're using
if your let's say invariant utilization is doing this
yeah, let's say that you have 8 tasks that have to do the same amount of work. The tasks on the big CPU will finish earlier than the tasks on the little because they are computing faster. That's the point.
Let's say, however, it's true that for us the division of fairness is within a CPU. There is no concept of fairness across CPU.
So I would, yeah, the fairness in a group of CPU in this case. I mean, because typically there is no reason.
No.
It's happening. I mean, it's happening, but randomly.
You could do it.
So instead of having that random,
I feel like
at least in the group, in one group, and then we can decide what should be the size, the group size, and the level where we should. But at least make that something we have decided and not something we are just waiting. That's my point. But I agree with you that another step might be, if needed, on a big little platform, if we need to do that.
And also because you still have the same problem even if you have 8 tasks in execute, the one that runs and the little one are kind of penalized.
Yeah, that's what
So
we
it's
were
not
saying.
that because you have 8 plus 1.
Yeah.
It's always 7.
Your tasks utilize the CPU to 100%.
Yeah.
So I agree that there is a fairness problem.
That's the case. Yeah.
But if they aren't, then
No. Yeah. If there is enough capacity for everybody, I agree. I agree. In this case, it's just a matter of using the spare capacity on the other CPU to finish it. So yeah, the goal would be to use something more stable and that we can control at least. Yeah, there is probably other use case that the 3 simple one that I have seen and studied for the last couple of, I would say, weeks. But so then, in order to fix that, we can start to have a look at the statistics that are used in the load balance. So right now, what we are using in load balance, so we are using the number of running tasks per CPU or per group of CPU. We are only using what we call the NRH running, which are the CFS running tasks. We should probably also take into account the number of running tasks on the CPU, just for the first use, the second use case, just to make sure that the CPU is really idle, in fact. And maybe also take into account CPU which are only running sched idle as a way to improve the latency and the performance. So for the utilization, we are using util average, which is no, it's not the spare capacity. That's that help you to estimate the spare capacity on a CPU. That not estimate the spare capacity. Sorry, it's a mistake. So, but the util average utilization can jump because of migration. Right now, the utilization of each task move with the task. So we can see a lot of jump and change on the utilization, which means that some CPU, when you have a lot of migration on overloaded use case, you can have a CPU which is not fully used from a utilization point of view. Just mainly because when the task migrate, it's remove some capacity, some utilization, and then the pelt signal needs some time to fill this gap. So we have utilest that is useful to, I would say, to mitigate this effect, but as I will show a bit after, it's not enough in some case. So we are using the load. We are using the runnable load for now. We are not using the load at all, mainly so the goal is, so the advantage is also its drawback. So the goal is that it reflects what is running right now. So that helps you to better balance the running task. But that also means that this runnable load change a lot. And sometimes, I mean, when it's changing too much, it's quite difficult to get any result from that, and to see if the system is rebalanced. So maybe we should also take into account the load, the block load in addition. Something similarly to what we are doing in the find idlers group, where we are using utilization, and if the utilization is close, we are using the runnable load, and in the last case, we are taking into account the block load as well to consolidate everything. And then we are using the capacity, which is the average capacity, the average available capacity, so the max compute capacity minus what have been stolen by interrupt, deadline, RT, and maybe the thermal. So on that, I mean, for now I don't see any needs of other value, but
Can I add just
yeah.
one comment on that one? The difference between utilization also and load is also that utilization we use only the root run queue value and the task shared entity values. We don't really care about task group shared entity, while it's not the same for load.
Sorry, can you repeat for
Utilization is not like a fix on your slide. It's just saying that there is a difference in the way we use utilization and load, which is at which level we use those values. Load has a meaning also at task group level,
yeah.
while utilization has a value, has a meaning only at the root, run queue, and the task scheduling entity.
Yeah.
This might be computed for all the hierarchy, so we propagate utilization across task groups without really needing it.
Yeah. Yeah. So yeah, that's what I was mentioning before. So when I'm running a Hackbench on my platform, so this is the utilization. So blue, it's util average, and green, it's the utilization of the root run queue. On the top, you have all the, it's a snapshot of kernel shark output. So you can see, we can see that the CPU is fully used. It's overloaded. But if you look at the utilization, we are far from the 1024 value, which means that we are fully used. Mainly because the tasks are migrating all the time, it's difficult to get something stable. So in this case, it's not meaningful. In fact, I mean, right now the load balance will say this CPU has capacity to take more tasks. If another CPU is overloaded, that will mainly create some kind of you will pull some tasks from another CPU, increase your utilization. The utilization of the other one will go below the 1024. So the other one will say, I have some capacity, so I can pull some tasks from this one that will be overloaded, and that's all. But yeah. Sorry?
The CPU hasn't been eyeballing long time.
No, yeah.
So that's always the case when you look at the utilization. You haven't seen idle time before. So one of the things you could look at is, don't look at utilization value if you haven't been idle within the last 20 seconds or whatever.
I'm not sure why you are using that. The utilization can be good even if you haven't been idle for a while.
If you have one task, one bias, it doesn't tell you much about how big the tasks are. So you have exactly the problem you were saying. If you have two tasks that are filling up CPU,
yeah,
and you decide to migrate one of them,
yeah,
also the CPU looks half busy,
yeah,
even though it doesn't really idle anymore.
Yeah.
That utilization is wrong.
yeah.
So perhaps what you could do is sort of look at when was the last time you had, and don't use the utilization value low. Like the overall life we have years, for example, not flag.
I've been idle for a while, and it just means that you didn't have to utilize 100%.
Yeah, he's just proposing you can use not idle as a filter.
Yeah.
He's saying if you have idle time, then you didn't have task stolen. If you have no idle time,
Right.
you might have task stolen. So you can just use that as a filter to take full utility.
So yeah, the other thing was mainly also to use the runnable signal. Right now, in the runnable signal, we have the waiting time, but we have also the wait, which is a problem. So, but in this case, you are able to estimate how much waiting time you have on your system, which means that in this case, if you look, and so if you look, so this is the load and the runnable load for the same, which stay really high. And the runnable just give you how much time you are waiting. So when the task migrate, if you have two tasks competing for the same CPU, the runnable will be 2048. If you migrate the task, the runnable will stay at 1024. But if they were not competing, let's say that you have the use case where you have two tasks which are magically, yes, in this case the runnable load will decrease below in this case. So you know that you're not, I can say that. You know that the tasks that remain on the CPU were not trying to get more. That's a way for you to know if there was some contention or not. That's probably not enough in all the use cases, but at least you can narrow the case, the unpredictable case. So yeah, we are using a lot runnable load in the scheduler, in the load balance, yeah. If I remember correctly, these have been added because the load in itself was not, I would say, dynamic enough for the share, the C group, yeah.
Which is saving cycles.
Yeah.
So we added Runnable later. Stagion found the regression with Facebook workload with C groups. Without C groups, there is no real difference.
Yeah.
But with C groups, we found that the load will basically be the block load of the C group. And so the CPU could be idle lots, but still have a significant load.
Yeah, but we split that out from the start. With the weight folding happens as separate optimization. We always had a runnable list blocks, but I think you're talking about, we chose between using the sum of them and using runnable to eliminate that, but what he's talking about, I think, was we didn't use to fold the weight into the sum. Someone else did that just to shave cycles.
Yeah, that's a mix of there was this other signal about the runnable things. But yeah, the point is that we have this runnable load right now. Maybe we should find something else and replace that by something more meaningful for the CPU. That will be my goal. But I agree that the main problem is how we are splitting or sharing the load of a group between each CPU, which is clearly the where we want.
Yeah, so we were load balancing on block load basically, and that moved way too slow.
Yeah.
So we had significant idle time.
Yeah.
And then we introduced
the sum of the runnable task load. That's what we have added.
Yeah.
So yeah, the goal would be maybe because we can't add more and more metrics. No, yeah, I understand that. So the goal is to see if we can remove some which are not really useful or use that in other way. And my goal would be to see if we can have the runnable state, which is the runnable time without the weight of a task, just to show the contention on a CPU and see how we can fix this task group sharing, which is based on the weight of each task in another way. Because we will be able to see if there is a lot of waiting tasks on a CPU. Because I haven't tried yet. Maybe I can start with something simple, which is the current runnable load divided by the number by the sum of weight. That should give you an idea. But I'm not sure. I mean, I will be almost all the time really below this capacity.
How does this work from Rick fits into this, where he wants to flatten the task group hierarchy for load balance?
Yeah.
It's not really clear to me.
So Rick is finding that Facebook spends too much time in walking the C group hierarchy, selecting a task. So it's the hierarchical NQ and DQ and pick that hurts them a lot. So he's now trying to flatten all that.
The group scheduling. All the runtime convergence breaks. I've looked at that before. This doesn't work.
Yeah, so it's sad that he's not here. But yeah, he's having fun with it. He's cursing on IRC every so often.
I've looked at it before. I couldn't make the math work.
Peter, how deep are the hierarchies that are walking?
I don't know.
So we have we have some numbers from database where they are, I think, having 3 level deep hierarchies. And we are seeing at times up to 7% impact on performance. We just haven't to analyze it because of keep our attention right now. But if there are patches around.
So I don't think he's posted anything. He's just been cursing.
Okay.
I mean, I know he has code and he's playing with it because he's posting stuff that doesn't. I mean, on IRC he's posting numbers that don't make sense, and then he's cursing and asking what went wrong. But yeah, he's not actually posted any patches yet.
So, yeah. I mean, one of the other problems we are seeing is there is a producer-consumer relationship between two different groups. And I don't know how much of an impact that is having as opposed to the scalability.
I don't know. I still run without C groups. I don't mean.
Now we know why it doesn't work.
I'm doing this. And I'm seeing some difference when running with and without civil. Even from a scheduling reason, or task placement reason. So yeah, the goal would be to find a way to track the waiting time. To see if we have some waiting time, I mean, just don't take care of the utilization because the utilization reflects what have been provided to the task and not what it's want to use. That's my main goal. We have few other things in the load balance, like the prefer assembling, where we are just modifying the classification and the statistic of a group to make it overloaded where it's not, in order to pull some task. So I'd like to tag the group with a special name instead of just modifying the statistic. Which it's better to say we want to balance between these two groups instead of just modifying the statistic, because you, at the end, what you are looking at, it's not a reality. We have this load per task statistic, which
That's an absolute bonkers.
yeah.
Delete it.
And that's what is mainly used in the fixed small imbalance, and that clearly this is used when you say, okay, I don't know what I want to balance, so I will use this value and hope that this will help me for the next load balance event.
So this got introduced, I think, when we changed to a weight-based load balancing in 2.4 something. Peter Williams did that. I wasn't doing kernel work back then. And it's only gotten worse ever since.
Yeah.
It was a 1 in the initial load balance patches. I think Nick Piggin did those. It was 1. And then we introduced weights, the weight-based load balancer, and it became load per task. And that was already dodgy. Yeah. And these days it's just a random number. It's absolute bonkers.
Yeah. Yeah. So the goal would be to replace that by some explicit force migration. When we are in this case, instead of using this, either providing I want to migrate a task, whatever the task, or one task, or one utilization, or whatever.
You actually just want like min load task on that rank queue, because it's more used as like a, can you move something to satisfy the imbalance?
Yes.
And what you actually want is a min load task.
So ideally, and I think we've talked about this before, and Vincent was also hinting at this, we should be looking at what we want to move. Do we want to move a task, anything, or do we want to move a load because we're in a load situation? Because initially we want to be work conserving, and we just want to get a task anywhere. Doesn't matter what task.
Outside of the possibility case, yes.
Run the thing. Yeah, let's not go there.
It depends. Like if you want to do my top one to be big task.
And then there's that, yeah.
Yeah. So, and even that, I mean, once you are overloaded, that you can still have what the best to put a big task on a little core and keep 20 small tasks which are more important than the big core, or doing the opposite. I mean, as soon as you are overloaded, the goal is to provide the same compute capacity for all tasks. And you can be in a situation where having this big task running on the little core and keeping all the high latency sensitive small tasks on the big core, that could make sense. You see my point? In this case, you don't have enough capacity for everybody. I agree that when you have enough capacity for everybody, you should provide more capacity for this one because there is more work to do. But when you are overloaded, you can raise the question. It's not sure. No. We was discussing about this. Sorry. What?
Would low per capacity solve that problem for you?
No, we were speaking about should I migrate any task, and Valentin raised the point that in big little you might not want to migrate a big task on a little. Right now the load per task is used when you want to migrate something but you don't know what. That's a fallback default value. Instead of doing that, the goal would be to say I want to migrate a task, whatever the task.
You can risk to enter like oscillations because then the big task on little becomes overutilized and then you trigger another load balance just to move it back.
Yeah,
so
I agree. I'm not saying that this will be easy, but I mean, we should. The point is that there, in this case, just that it's random. And in some case, you are migrating something, and in other case, for example, typically if you're going to this use case. So there, we have these 5 tasks on 4 CPU. So we are migrating, and for this it's on on CPU 6. This show the load balance event on CPU 6. So in this case, that a task is pulled. In this case, we are not putting any task. And when you look at the statistic, there is no difference. The difference is just a matter of 1 or 2 in the load or the capacity because of the fact that yes, exactly. And the noise decides for you.
But it's not in that case that we should not even look at load as a matrix. We just want that one task per CPU. We just have to look at that matrix.
Yeah.
Instead of one task per CPU.
I agree.
Looking at number running.
I agree. But yeah, it's just that it's just that the main goal for us is to migrate the tasks there. But because we are in this situation when you have 5 tasks on 4, you can't have 1 task per CPU.
This point is that you are migrating for no reason because of the noise. When the noise decides, whether or not you migrate something.
There are 2 problems.
Yeah.
Problem 1 is that we're not using CPU 0. Problem 2 is that 5 on 4 split is asymmetric.
Yeah.
True.
So most of the discussion has been assuming we fix problem 1. What can we do about the asymmetric split in problem 2?
Yeah. But again, for the problem 1, you're saying we cannot do anything because there is noise. Maybe the noise is
No. For problem no.
Problem 1 is just a bug.
Now for problem 1, I agree with you that this is a case where we have an idle CPU and we have not 1 task, 2 tasks on another CPU, and we'll have to migrate. We don't care about the load. We don't care about anything.
Okay, so let's fix it.
So problem 1 was the HNR running and our running discrepancy.
Okay,
It's nothing to do with
right.
it.
So let's assume this is fixed, and you're saying there is another problem.
There's another problem, which is if you have 5 on 4, then the asymmetric distribution time is some problem. 3 on 2 is like a really clean way to look at it.
Yeah. Yeah, but then in that case you go back to the idea that we should define fairness across CPUs, which is not really
which is that second problem.
Yeah.
Approximate.
So the goal would be to remove that and replace by some simple decision.
And that asymmetric capacity, actually, to be clear, is not just because of big little. It
No.
can be because you have RT load.
Yes, yeah.
It can be or thermal pressure or
There's no stable solution.
Exactly.
Yeah.
So you have to have something dynamic.
Statically infeasible.
But wait a minute, like this problem, sorry.
Yeah, go on.
The HR running and the running stuff, those tasks were only CFS tasks right now, right? So it's not solved by introducing or knowing which tasks are running in RT or...
You mean this
For
one?
example, was purely 8, no, the other one. We had 8,
Yeah.
those are 8 CFS tasks.
Yes.
So the solution to use NR running instead of HNR running is not really replicable.
No, that's
Okay,
that's
cool. I just wanted to.
that's I mean that's for
That was the ask.
this one.
That's right. Okay.
And the goal is not using the other one, but to use both. I mean,
okay.
I don't know, at least to know if the CPU is already used by another scheduling class.
Yeah, it's not only the introduction or the influence of other shared classes onto the capacity, it's also on the number of tasks running at the moment.
Yeah. So another metric that we could remove is the sum of weighted CPU load, which is equal to the group load, since your patch that have disabled the...
But this patch was only introduced to check if we see some influence on CPU load array, right? It's not really, we should not
The load
take
array
this.
itself is also.
Yeah,
No,
So
The load array itself.
So we
is-
merged this patch to see if anybody would notice.
Exactly.
I think
So
by
far
now we
nobody.
can agree that nobody did notice.
So you are happy to see the other patches to remove like 600 lines of code?
Sure.
Okay.
Let's just do that. And see if somebody
Anyone
notices that the code that didn't do anything went.
and even more, we don't need this one anymore. I mean,
Actually, I wouldn't do that for every line of code that nobody can explain.
Well, yeah, that's the
But then you-
plan. Like we are slowly. I mean, it's just like it's 490. You have to give them a few releases to, and want to bet that as soon as some enterprise distro uses 419 or later, which might or might not happen. So RHEL 8 recently happened. What are they running?
I think that I have started to see 01 some performance result.
With 412.
With on both.
Yeah.
Some are
The
raising
next,
regulation, others improvement.
Yeah.
not decided yet, but after 5.
Okay, right. So.
Throw them over the wall for the competitor.
Slowly converging to the non-scheduled.
Yeah, so the fix small and balance, I'd love to see that function die. It's just horrible. Right along with load per task.
Yeah.
And the CPU load array.
Oh, yes. So we just agreed to kill
And just
CPU load
essentially
array.
saying all three of them. For completeness, if we're enumerating them.
Yeah.
So the goal would be to use H running, maybe scheduled idle task state, the utilization, which is the max of utility average and utilized. The Runnable, in the sense, the goal would be to change and to reflect the waiting time on the CPU, and not the Runnable load average. So using the load average instead, which is there, or I mean, and the capacity, and that's all for the statistic.
So for
Yeah.
idle and idle values, could we just almost not use any statistics if we go with like CFS stealing from CFS star and then maybe some show stuff for misfit and async packing just to do something to fix? We don't really need stats.
So the stuff from Steve's Star only did it to the NUMA level, and after that we had weird artifacts, and then we ended up with some new idle balancing in 2 different ways. So yeah.
But we could be, because I think you mentioned that someone tried killing idle values and it would be something similar.
Well,
So that's
you, I can't remember, but yeah. So I love to see the stealing stuff work as a full replacement for the idle. I know there's some partial replacement, but yeah.
Then there is the, how many?
5 minutes.
5 minutes? Okay, I'll go quickly. So yeah, this is not, so yeah, that's where most of the job is happening, updating statistic and classify the groups. So right now we are classifying the group of CPU. So we have 2 default states, which is others, which mean, okay, we have some load. We have overloaded. Then we have some special case for imbalance, for when we have too much pin task or we are not able to find the best way to do that. We have the misfit task use case always, and we also have some shortcuts in different place for the async packing use case. So the goal would be to remove this use case dedicated. I mean, we have imbalance. The case of imbalance is that we want to migrate the task and see if that make the picture easier to solve.
Yeah, so the imbalance infinity mask, either directly per task or goes through C groups, that spans balance domains and it's not symmetric in that. So it has, say, 2 CPUs from one domain and 3 CPUs from the other. The load balancer gets mightily confused. Yeah, and then that's where the imbalance.
That's. My point is that it's clearly tagged to solve this problem where the goal is try to find a task to migrate. And instead of doing that, saying we are in the imbalance, we are in the misfit, we have the async packing. It's just to say that, so we have some states which are IF capacity, for example, because right now we still maintain another field to say this group has capacity or not. So just tagging the group to say I have capacity, I'm fully busy, I mean, I'm used but not overloaded, so try to not change my state. Or I'm overloaded and I need help. That seems to be the 3 main use cases for us. And then we have some use case where the load in itself doesn't mean anything, where, I mean, I want to fill an empty CPU. I mean, if I have one empty CPU or one idle CPU, we don't really care about the load. I need to fill it with a task that is waiting on another CPU. I have to move a task. I don't care, but at least one to try to fix this imbalance. So instead of making that use case, just saying we can do some action. So we can reuse this action for some other more complex use case. I want to move a minimum load or a minimum utilization, or I want to move a dedicated task, like for the misfit. We know, in the case of misfit task, typically we know which task we want to move. So that's quite easy. We don't have to take care of the other, trying to, I mean, just migrate this task and that's all. That would be my case. So we can reuse that for other use cases as well. Yeah.
One interesting is if there are any tasks that we can call if we have task affinity. And I don't know if anyone has actually tried to type this in tasks. Because we have imbalanced, the group imbalance.
Yeah.
We can detect it. But sometimes what we have is we pick the group as the easiest one. There's actually nothing we can call.
Yeah.
Nothing, whereas we could have tried to call the task from the group.
Yeah, so I don't think anyone plays with this.
I thought we have OPM, it's like super.
Yeah, that's just the job.
And this intersect, we have.
But doesn't this imbalance case and affinities, I think it's used because you're trying other CPU in that case.
I think that one is in ways when you actually pull something, but you still have non-zero imbalance, and you saw that there was some task affinity. But if you have a group that has everything in and the local imbalance is pretty I'm not sure.
Maybe there are some use cases that are still
so create 100 tasks, spin them all to one CPU, and then see if the load balance.
Yeah.
So it will always pick that one CPU.
Never done trigger open, and then it'll trigger, then we repick.
Yeah, but it'll take.
Oh yeah, right, we loop again.
That's why we come out to auto bounce and we see all pinned and we repick and we try again. And then it's only some, then you go to some pinned and you add a collapse to actually moving something or going back to all pinned because some pinned things to move. But it's all there. It's solving the problem backwards because there's no, you only have a point, there's no top level visual. There's no way other than the point-wise task representation to understand those parts, like the pins. So
the goal, the policy would be, we have this normal case, I would say, when we overloaded and we have a lot of tasks and we need to balance. The other use case which are specific, the one I mentioned. And the goal would be also at the end that the imbalance should not always be a load, but can be either a load, an utilization, or a task. I mean, and that's that's. Sorry. Yeah.
In the last point, and I special.
Yeah, maybe.
That shows up as cat.
So right now we have we are running some case right. You would like to have that as another system?
Certainly, but this is the case to consider.
That should, under the way we have everything else, that should be a capacity.
That's all.
You mentioned shed idle. Do you mean the shed idle policy?
Yeah. Yes, what Viresh have started to work on the wake-up pass. Maybe we should extend that as well.
Okay.
Because we can see there was some tests with this Facebook guy, and we see some improvement, and probably there are a few other paths which need to be modified as well.
It's probably the sub-classification of in CFS people would like to have in certain use cases. That you treat certain set of tasks differently than others.
Yes, exactly. And we have at least this one. Maybe the next will be the skate batch. I don't know. This one is really obvious. Thank you.
Okay, thank you.